So 8A.5, last lesson of 8A. We are going to be solving equations where the variable is in the base. So we've actually done problems similar to this already, so some of this might be review for you. First step is you want to get the exponent or the term with the exponent. Sometimes it might be quantity, but you want to get it by itself. And then to get rid of the exponent, you are going to raise both sides to the reciprocal power, which we did with roots. And then you are going to be able to solve for x. Okay, example 1. We have x to the 1/2 equals 3. So we have our exponent term by itself already, so you're going to raise it to the reciprocal power, which is, in this case, 2/1. So when you raise a power to a power, you multiply them. So everything reduces here. The 1/2 is an exponent. So that's x equals 3 squared, which means x equals 9. Which should make sense, because if we were to take x and plug it back in, 9 to the 1/2 power is the same as the square root of 9, which is 3. Okay? X to the 3/2 equals 8. Do I have my exponent? Yes. So we're going to raise both sides to the reciprocal power, which in this case is 2/3. So everything reduces here. And we get x equals 8 to the 2/3. That's the same as the cube root of 8 squared. You could square inside the cube root, and you would still end up with the same answer. I think it's usually easier to take the root and then square whatever you end up with. So what is the cube root of 8, guys? 2. And 2 squared gives us x equals 4. Okay. So, like I said, if you had written this as the cube root of 8 squared, that would be the cube root of 64, which is also 4. So you would end up with the same thing. I think it's just easier to take the root and then square it at the end. So then you're only taking roots of smaller numbers. Okay. All right, example 3. We have 4 times x to the 3/4 equals 108. In this case, my exponent term is not by itself yet. There's the 4 attached to it. So we have to divide by 4 first. So that gives us x to the 3/4 equals 27. And now we can raise both sides to the reciprocal power, which is 4/3. So your exponents reduce on the left. We get x equals the cube root of 27 to the 4th. Cube root of 27 is 3, and 3 to the 4th gives us 81. So example 4, 2x to the 2/3 power equals 50. What did you guys do first? Good. So you divide by 2. That gives you x to the 2/3 equals 25, and then you raise both sides to what? Good, 3/2. So that's going to be x equals the square root of 25 to the 3rd power. So that's x equals 5 to the 3rd, so x equals 125. All right, example 5. X minus 2 to the 5/2 power minus 5 equals 27. So in this case, there's 2 things that are different. The most obvious thing is that we have an entire quantity being raised to a power. So that entire thing, x minus 2, is what we call the exponent term, okay? Because it's an entire quantity to a power. So we're trying to get that whole thing by itself. The other thing is that we're subtracting 5 from the back of it. So first, to get that entire quantity by itself, we need to add 5 to both sides. So that's going to be x minus 2 to the 5/2 equals 32. And now I have the whole exponent term by itself, so I'm going to raise it to the 2 over 5. So then those exponents will reduce. So we will be left with x minus 2 equals the 5th root of 32 squared. So that's x minus 2 equals, guys, what's the 5th root of 32? 2. And 2 squared gives us 4. So this is x minus 2 equals 4. Add 2 to both sides. So you get x equals 6. So example 6, this one's a little bit different, but the idea is still the same. We have 1/5 times x plus 2 to the 3 over 2 equals 25. So this x plus 2 to the 3 over 2, that is going to be your quantity raised to the exponent. So that's what we're trying to get by itself. So what do you guys think we should do? So if we multiply by both sides by 5 over 1, that 1/5 is going to reduce, and we would be left with x plus 2 to the 3 over 2 equals 125. And now you can raise both sides to the power of 2 over 3. So everything reduces. You get x plus 2 equals the cube root of 125 squared. So that's x plus 2 equals, the cube root of 125 is 5. And 5 squared gives us 25. So when you subtract 2 from both sides, you get x equals 23. So here's one where we're going to put both of those ideas together. So example 7, negative 2 times x minus 7 to the 1/3 power plus 5 equals 21. So what did you guys do first? Okay, so let's subtract 5. So that gives us negative 2 times x minus 7 to the 1/3 equals 16. And then what did you do? Good, divide by negative 2. So that's x minus 7 to the 1/3 equals negative 8. And now we can raise both sides to the 3 over 1. So that gives us x minus 7 equals negative 8 to the 3rd power. What's that give you guys? Negative 8 to the 3rd. Negative 512. And then add 7. So you end up with x equals negative 505. How many of you got that one? Good. So example 8. We have 3x plus 17 to the 4 over 3 equals 16. Is my exponent term by itself? Yeah. So raise the whole thing to the 3 over 4. So that's saying 3x plus 17 equals the 4th root of 16. And then whatever we get, we're going to raise that to the 3rd power. Fourth root of 16 is 2, and 2 to the 3rd is 8. So that gives us 3x plus 17 equals 8. And then solving this should be a piece of cake. Subtract 17. So 3x equals negative 9. Divide both sides by 3. So you end up with x equals negative